Okay. Yes. Let us start. So what we have seen variables. Hello. Yes, we have seen variables, and we have seen that we cannot have spaces between variables when we are writing on SPSS program or on any Excel program. Okay. And we have seen three different types, mainly three different types here. There are interval and ratio. We have seen what is nominal, ordinal, and we define this as scale. Okay, so nominal is grouped variables where the order is not important, and here, for example, names and classes. We have seen this. Ordinal. Okay, ordinals can be order. Okay, this is the SPSS program, so I'm going to use this also. It's a statistical program. Yes. Okay, so we can have like mild, moderate, or severe. We can define variables as mild, moderate, severe, and this is ordinal because the order is important here. And we can have scales, and the scales are just numbers. So these are variables. We have seen this before. And yes, for example, let us look to this example here. We have two tables, okay, and the first table is the table of frequency of distribution of age, okay. So let us say that we have a set of 26 students, and the frequency means that number of children, okay, with the age of 1, okay, children with the age of 1, number of children with the age of 2, okay, frequency is that, number of children with the age of 3, number of children with the age of 4, number of children with the age of 5, number of children with the age of 6, okay, and these are the frequency numbers. Age group, okay, we can define this frequency as this. We are grouping them, okay. Let us say that we want to have 3 groups here, 1, 2, 3 groups, okay, and we can, now this is an ordered group, it's ordinal. If we define a variable age, okay, this is ordinal, and here the frequency is 8. This means that I have 8 students which are in this age group, and I have 12 students in this age group and 6 students in this age group, okay. So how I find it, look here, 1 and 2, okay, the ages of 1 and 2 is in this group here, okay. So okay, 1 and 2 is in this group, so 5 plus 3 is 8, okay. 3 and 4 is in this group, okay, and here 7 plus 5 is 12, and here 5, 6, age group 5, 6, 4 plus 2 is 6. What is important in these grouped frequencies? The important thing here is that we start from 1, 2, the next element is 3, okay? So we cannot start from 2, we cannot start from 4, because there will be a gap. If we start here from 4, then what happened to 3? Okay, we have a gap there. So we have to have integer groups here, and it should start from the one bigger number, one higher number. Okay, so let us look to this other grouping here. Cumulative frequency of data in previous page. So here we see that 1, 2, 3, 4, 5, 6, these are the ages, and these are the number of children with these ages. So cumulative frequency, we have 5 here. Look how we calculate it. Okay, 5 plus 3 is 8, okay? And here we see that 8 plus 7 is 15. So cumulative frequency is adding the next one. So 15 plus 5 is 20. 20 plus 4 is 24. 24 plus 2, 26. So all together I have 26 children with these ages. Okay, so this is frequency of data. Okay, here. Age group, the ages between 1, 2, 3, 4, and 5, 6, okay? The idea is same as you can see. This the frequency is 8, here the frequency is 12, and here the frequency is 6. Okay, now here this is 8, and here the total is 20, and here the you can see that 20 plus 6, we have altogether 26. Any questions until now? Okay, so this is important. We can have some outliers, okay? So what is an outlier? Okay, so here, let us see the outliers. This is the outlier here, okay? So let us see some other examples of, these are the outliers. These are out of the group, okay? Let us see some other outliers. So this is an outlier, okay? It's out of the group. And this is an outlier out of the group, so it's important. So in our research studies, if we have an outlier, we have to take it away of our study, okay? Because it will affect our research. We have to have people in our research group who have similar facilities, okay? If one of them has a different illness, okay, he's an outlier, he's a different case, okay? So we have to think, for example, if we work with 121 now, if we have small dots, okay, if we have a person who is too fat, okay, let us say 200 pounds, which a lot of weight, okay, very heavy, and the other people are in the normal weight, then we have to consider that special person in a different group. He is an outlier, okay, that's the outlier. So let us see some more examples of outliers. This is an outlier, okay? If this is my samples in my research, then if I take this value, this is a very high value, and if it will affect my result in the wrong way, okay? Because it is only this person's case, okay? The other people have different and similar properties, facilities, but this person has a special case, okay? So we can consider it, we can take it out of our research, and we can consider it in a different group where all the other dots are here, okay, are similar.
As an exception, yeah?
As an exception, yes, a difference, yes, we can say as an exception. But in statistics, we say outlier. Okay, here, this is an outlier. This is an outlier, okay? So this is an outlier. It's good having seeing different examples here. So this is an outlier. Look here. All the other spots are close to each other, and we have an outlier here. So we have to take this person out of the research study. Now here you see that this is okay, but we have several outliers. We can have cases where we can have, these are several outliers, okay, outside of the concept. I think you understand what is an outlier now. Okay, so let us continue with our presentation. So we can have outliers, and we have just seen that we have to omit these outliers. Yes, a bar diagram or pie charts are used for categorical variables. What this means, if we can write them in groups, if we can categorize them, we can use bar graphs, okay? That's better for them. Histogram, stem, leaf, and box plot are used for numerical variables. I can ask this question. This is a good question in fact. For example, which one of the following can be used for categorical variables? and you will say bar diagram, pie charts, okay? Or choose from the choices, or which one of them are used for numerical variables, histogram, stem, or leaf, or box plot. Yes, here. Data presentation for categorical variables. This is 1, 2, and 3 here. You can see 1, 2, and 3. Frequency, frequency 15, frequency 25, frequency 20. It's number of times that it's happening. And here you can see the proportion, okay? What is the proportion? Or we can, proportion is, it's 60, okay? So 15 over 60 is the proportion, and we can express it as percentage here. We can have such graphs. And it is good here, 1, 2, 3, because it is in categories. It's groups. It stands for groups. Now here, pie charts stand for percentages, okay? If you have a wall, what is a wall? 100%. A pie is 360 degrees, it's 100%. We think it as 100%, okay? And so here 33, 25, and 42 is we sum up 100, okay? So it's for these representations. Now, if we are using these percentages, we use pie charts. If we are using these proportions like 15, 25, 20, we use bar diagram, okay? For bar diagram, we use frequencies here, bar diagram frequencies, and for pie chart, we use percentages. Okay, now here, this is histogram, okay? So what is this histogram? Here, shape, center, and strip, it can be described with these properties. Now, you can see that this is right skewed, okay? There is no normality line. Now, the line going here and coming here is called normality line, okay? It doesn't have a normality line. It's just an histogram, okay? What is the difference of histogram from a bar chart? Who's going to say me? Look here, this is histogram, and that's bar chart. What is the difference?
There is the space.
Yes, with bar chart, you have spaces, okay? You have spaces with bar diagram, okay? And with histogram, you don't have spaces, okay? Yes, and here we have no outliers. These are the statistics here. Now, this is box plot, okay? These are representations, graphical representations. We have seen mainly, now here we have seen bar diagram.
Doctor, why in the first one have space and the second no?
That's good, because here these are categorical. This is group 1. This is a group, okay? This is a group. For example, like here we have seen groups. For example, here 1, 2. These are for groups, okay? And here you don't have space. It continues here, okay? So it's not group. This is the main difference. Okay, so this is called box plots, okay? As we see box plots in biostatistics and in blood tests, they provide you with graphics, okay? To see, for example, distribution of diseases, okay, with this box. And they have different meanings, of course. Now here, when we see a box plot, what we understand here, we see this is, you see that this is not equal, okay? And now here, Q1, it says Q1 is this line, minimum, median, and max. Here, this part is bigger, this part is smaller. So this representation is called box plot. Now, we have represented with graphs here, okay? And we have numerical representation. Numerical representation, for example, here, let's have two samples here, two sets of data, which one set A consists of 30, 50, 70, set B consists of 40, 50, and 60. And if you calculate mean, you find that it's 50. Okay? They are different numbers, but the mean is same. Calculated. 80 plus 70 is 150 divided by 3. Do you want me to do it? Let me do it. Okay. Now here we have two sets of data. Set A, let us find mean of set A. Mean of the set A, okay, here. And we see that 30 plus 50 plus 70, okay, over 3. Okay, so what is this? 80 plus 70 is 150 over 3, and that's 50. Okay, so let us find mean of B. Mean of B here, okay, this is equal to, so we have 40, we have 50, and we have 60 here, okay, we have this, and you see that it's again same here, 3 equals 3. Yes, we have different distributions, okay, but we have same mean. It's possible to have same mean if we have, even if we have different distributions. All right, so now we are in PowerPoint. Okay, continue. Now, yes, this is how we find mean. Median, we learned it. So what is the median of these distributions? It's just only 3 points, but median of A what is median A? What is it? 50, good. So what is median B? Ah, that's good. Then can we say that this is a normal distribution? Mean median is equal, okay? Yes, and mode is 1. Mode of is 1. Frequency of 30 is 1. Frequency of 50 is 1. Frequency of 70 is 1. So these two are normal distributions. But what we see here, we see that mean, median, mode are equal, therefore they are normal, but they are different numbers. It's possible. Okay, so here, range. What was range? Range is, let us see this distribution here, 10, 5, 200. Okay, it's a different distribution, and the range is you subtract from the highest one the lowest one. Okay, so 100 minus 2 is 98, and it's the range. Thank you. What about the other attendance paper? So it's okay, if you want, I can give you one more paper. It's not important whether you... One more paper? Excuse me? Yes, paper, no?
There's student they are signing.
Okay. 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 Yes, now, here, what is variance? Let us see this variance here, okay? Variance of a set of observations is the average of the squares of the deviations of observation from the mean. What it means? So, if you take a number from the sample and subtract its mean, take its square, and do this for all numbers. Divide by n minus 1. You find variance square. Yes, it's a little. Yes, it's a little bit different calculation. Let us find here. What is the mean here? We add them and we divide by 3, so 5 is the mean. Okay. So what is variance? You have to know this. We are going to do some examples about this and until you learn it. Okay. Yes. We subtract here 5, the mean, and take the squares. Divide it by number of elements is 3 minus 1 and 4. 4 is the variance. This is important in our calculations and in biostatistics. Standard deviation is the square root of variance and it is 2. Let us have some more examples here. No, it's okay. So let me solve some examples. Okay, this is the formula. Let us have this sample. Okay, this is a sample. Find, here is the equation. I want you to find your notebooks. Find mean, median, mode, variance, and standard deviation. Yes, here is the equation. Please solve it by yourselves now. Now here, I have these numbers. Okay, the mean. In order to find mean, I have to add these numbers. So what is this? 5 plus 7 is 11. 28.
4 divided by 8.
Yes.
It's 5.
Okay, so here the mean is 5. Agree? Any questions? I add all of them and divide by 8. Median, I have to order them, okay? I order them. 1, 2, 3, 4, 6, 7, 8, 9. Okay. We have 4 and 6 here. Okay, that's good. I add them and divide by 2. That's median. Okay. That's another paper. You can write here. Students who didn't write, you can write there. Okay. Now here, I have 4 and 6. Okay, I add them and divide by 2, and that's 5. So median is 5 here. Okay. Any questions? No. So what is mode? Mode, we can say we have no mode or yes, all of them are mode. No mode we can say. Here, range. What is the range? That's good. Okay. Equals to 0. No, it's equals to 8. Yes. Now here, variance and standard deviation. Let us find this. From this formula. Look here. Now, here. Let us use this formula for finding variance. Excuse me. Let us find variance equals to divide by 7. Excuse me, let us find variance. Now, x1 minus, what is the mean? 5. 1 minus 5, okay? Square. So that's 4 square. Let me write it here. So 1 minus 5 to the power 2. Do you understand what I'm doing? Yes. So that's the formula. So that's 4 square is 16. The first one. The second one. 2 minus 5 to the power of 2. So what's that? 9. Good. Now the next one. 3 minus 5 to the power 2. What's that? 4. Good. Now 6 minus 5 to the power 2 is 1. 7 minus 5 to the power 2. 8 minus 8 minus 5 is 3 to the power 2, 9. And I have 16 here, okay? So I add all these numbers and I divide by 8 minus 1. I divide by 7, that's variance, okay? Divide by 7, you get, total is 59 over 9. So that's 8.32. Okay? Wait. So I divided with which number? I divided with 7. Okay. Yes.
And the steps for variance and standard deviation.
Oh, yes. Now here, let us, excuse me, this is important. Please watch here. This is the last question and we are going to finish the course. So, here, this is x to the power line is mean, okay? Mean here is 5. We have mean 5. Okay, so x1 minus 5. So, we are going to subtract 5 from all the numbers here, okay? Yes, now here I have 1 minus 5 to the power is 2. And take it square. 2 minus 5 to the power 2. 3 minus 5 to the power 2. And I add them, divide by 7. Why 7? That's the formula. N minus 1. Okay?
Every time it will be 7.
Yes, and that's a variance square. Variance square, okay? Variance to the power 2. Variance to the power 2. That's variance square is this one. So what is variance? Variance equals to 8.32 square root. Okay? And what is standard deviation? Standard deviation we have seen here, okay, in our slides, we have seen that square of the variance. So we take square root for finding variance, and yes, wait, now, so standard deviation equals to 8.32. Okay. Square root of standard deviation is variance. Okay, any questions? No? Okay, so